So we're going to finish up trigonometry and talk about the law of cosines. Again, you can take a whole class on trig, I think even at the college. So we're just getting a little bit of an introduction into what you can do with trigonometry. But a lot of this, like I said, it's formulas but trig is pretty cool when you interact with the world with it. Get some pretty cool problems if you ever get into questions involving like the GPS system and things like that. How the world of satellite traction stuff like that. Because remember, there's this vectoring going on. There's magnitude and there's direction. A lot of times when magnitude and direction are present, trigonometry is not too far away. So in the law of cosines, we want to find the unknown parts again of an oblique triangle. This time, if we're given three sides of a triangle. So remember, the law of sines, there has to be at least one angle given. And it depends where that angle actually is given at. But law of sines works best when you have two angles given in one side. But if you don't have any angles at all you have is three sides, then I can find the missing angles by using what's called the law of cosines. Now, keep in mind, though, all we have to do is find two angles, because if you add the first two together and subtract that from 180, that'll give you the third angle. So technically, if we know three sides, all we have to do really is find two angles with trig, and that third angle can be found by just basic math. So the law of cosines kind of works like this. So it's got this a squared equals b squared plus c squared minus 2bc cosine of a. So the way this translates for me is it's the in some plain language here, we have the opposite squared is going to equal the adjacent squared plus the adjacent squared minus 2 times the adjacent times the adjacent times the cosine of the opposite angle. So we have that kind of going on. You also can kind of solve for the cosine of the opposite of the angle. So the cosine of the opposite of the angle is going to equal, that's going to be the opposite squared minus the adjacent squared minus the adjacent squared divided by -2 times the adjacent times the adjacent. But if I bring this negative through to the top, the signs on the top will switch. So it's going to actually become the adjacent squared plus the adjacent squared minus the opposite squared over 2 times the adjacent times the adjacent. So if we understand this language here, we don't have to get in all this A, B's, and C stuff. So if I look at this example here, if I want to find the angles of this triangle ABC, notice how we have been given the three sides. So I need to find angle A, angle B, and angle C. So suppose we start with just finding angle A. If I find angle A, notice that 7 becomes the opposite, and the 5 and the 8 become the adjacents. So if I use the formula to find the angle, so that's going to be the cosine of angle. The angle is going to be the opposite angle there. So the cosine of A is going to equal, then it's going to be the adjacent squared plus the adjacent squared minus the opposite squared over 2 times the adjacent times the adjacent. So this ends up being then, the adjacent was 5 squared plus the other adjacent was the 8 squared minus the 7 squared divided by 2 times the adjacent. Oops. So 2 times the adjacent times the, I did it again. Let's actually put the numbers in there. Okay. So the adjacents are the 5 and the 8. So 2 times 5 times 8. So that's going to be the cosine of A. Notice though, we still got to do the inverse cosine of that. So the inverse cosine of that is going to be our answer. So 5 squared plus 8 squared minus 7 squared over 2 times 5 times 8. So if I want to modify this formula even further, the inverse cosine of the adjacent squared plus the adjacent squared minus the opposite squared over 2 times the adjacent times the adjacent would really be the formula that we're looking for in this problem. Since we're looking for the angle, we really need the inverse cosine. So see if we can actually get this to come out for us here. So again, the first thing you got to pick up on is with your calculator, you got to make sure you're in degree mode. So if I hit the mode button, notice how mine is still in degrees, so we haven't changed it since then. Okay, so we kind of gone back and forth. So if I do the inverse cosine, and then this is kind of a fraction, so alpha f1 number 1. So if I put the 5 squared plus the 8 squared minus the 7 squared, on the bottom we would have, well, 2 times 5 is 10, 10 times 8 is 80. So I'm just going to go ahead and just do that math, close it out, and our angle is going to be 60 degrees. Well, okay, that's kind of nice. So what we just found was angle A. So angle A is 60 degrees. I didn't give myself much room, did I? Let's see if I can make this stuff move here. So if I want to find angle B now, so angle B, we'll do a different color here. So notice that now all bets are off on who's opposite and who's adjacent again. So if I erase this all off here, if we're now looking at angle B, notice that now the 8 becomes the opposite, and the 7 and the 5 are now the adjacent. So things switch based on which angle we're talking about. So if I use my formula that we created over here, the inverse cosine of, you notice how I say adjacent squared plus adjacent squared, that's going to be the 7 and the 5. So the 5 squared plus the 7 squared, then minus the opposite squared is going to be the 8. And then this is going to be over 2 times the adjacent times the adjacent. That's going to be the 7 times the 5. Or 5 times 7, doesn't really matter. So if we do that in the calculator, inverse cosine of, again, that's really 25. Let's go back and make a fraction of second. Nope, alpha f1, number 1. So really, I know that 5 squared is 25 plus 49 minus 64. On the bottom, that's 35 times 2 would be 70. We can do a little bit of math along the way if we want. And enter, and that'll give us 81.8 degrees. So angle B is going to be 81.8 degrees. So So again, to find the last angle, so we found AB, so to find the last angle, angle C, we can add these two angles together and subtract from 180. So 180 minus the 60 plus the 81.8. So 180 minus then those two, 60 plus 81.8. Or you can subtract them one at a time if you want. Enter, that'll give you 38.2. So 38.2 becomes angle C. So 30.2 degrees. Now, again, if you don't like all that parentheses, you could just have gone 180, take away 60, and then take away 81.8 like that. That'd still give you 38.2. So if I look at this example here, if we want to find the angles, so again, we can start with angle A. If I do, this becomes the opposite, and these become the adjacents. Remember, the adjacents are sharing the edge, and the opposite does not share that edge. So if I use my inverse cosine, my formula says to go the adjacent squared plus the adjacent squared, so it's going to be 8 squared plus 9 squared, minus then the 15 squared, all over 2 times the adjacent, which is 8 times 9. Let's phase that, we get our answer. So inverse cosine, let me clear this off, it's getting too busy. So inverse cosine, and I'm going to use the alpha button, alpha F1, number 1. Again, if you want to just type in 8 squared plus 9 squared minus 15 squared, you can move down 2 times 8 times 9. Come out of there, close parenthesis, hit enter, and I'll give this angle A is going to be 123.7 degrees. I'm feeling pretty good about that because angle A looks like it's an obtuse angle. So if I want to find angle B, I have to reload my triangle. That's where pencil, paper, and eraser come in really handy. So I don't have to draw the whole shape over. We now can focus on angle B. But also, if I do angle B, this becomes the opposite over here. And this becomes the adjacent. And this becomes the adjacent. So if we want to find angle B, we have to use the inverse cosine of, then it's the adjacent squared. So it's 15 squared plus 9 squared minus the 8 squared, the opposite squared, over 2 times the adjacent, which is the 15 times the 9. So I'll give us our answer there. So second inverse cosine, I'm going to again just use a fraction, number 1. So 15 squared plus 9 squared minus 8 squared, drop down, and 2 times 15 times 9, come out, close parenthesis, hit enter. That's going to be 26.3 degrees. So angle C, we can find that by subtracting A and B from 180. So 180 take away 123.7, and also take away the 26.3. That gives us 30 degrees. Okay, so that's how we can use the law of sines. If we know three sides, it can help us find some missing angles. Let's see what else we got here. A couple applications. All right, let's look at example 3. Notice how we have an angle, but now we don't know a side over here. But notice how this is the opposite side. So if I want to find that opposite side, we can use the reverse formula, which is the opposite squared is going to equal the adjacent squared plus the adjacent squared minus 2 times the adjacent times the adjacent. And it's going to, I don't have enough room for that. I almost have to modify that one down. Let's see, make sure we got here. Yeah. So try it again. So come a little bit. So the opposite squared is going to equal the adjacent squared plus the adjacent squared minus 2 times the adjacent times the adjacent times the cosine of the opposite angle, which is going to be, in our case, angle A. So you can kind of see why they like these letters, but if you don't know what those letters stand for, then it's confusing. So I'm actually finding A here. So to find A, we still got to take the square root of all this. So remember, when you do, you're supposed to get a plus or minus, but remember, sides of triangles and stuff cannot be negative, so we can ignore that. So if I go and take the square root that I have to substitute in, then this adjacent squared would be, so let's go 6 squared plus 5 squared minus 2 times 6 times 5 times then the cosine of 42. So that's all we got to do is put that in the calculator. So second square root, we have this 36 plus this 25 minus, what's that, 60 cosine of 42. That looks good. Yeah. So we end up with, then A is going to be like 4.1. And to find some missing angles here, we could use the law of sines to find an angle. We don't necessarily have to use the law of cosines here. So if I want to find angle B, well, actually, I don't think we want to round. That's just too aggressive. So let's stick with the law of cosines one more time here, because there's going to be too much rounding going on here, because we have too many angles missing. But I take that back. I can go the other direction. No, I need the opposite angle and I don't. So let's stick with the law of cosines. So if I want to find angle B, this becomes the opposite. This is going to be the adjacent. And the A we just found was 4.1. That's going to be the adjacent as well. So we have the inverse cosine, and it's going to be the adjacent squared, which is 4.1 squared, plus 6 squared, minus 5 squared, over 2 times the adjacent, which is 4.1, times the adjacent, which is 6. So that will help us find angle B. So we'll clear that all off. So inverse cosine of, let's make a fraction. We have 4.1 squared plus 6 squared minus 5 squared. On the bottom, we have what, 12 times 4.1 0.1. That looks okay. So angle B is going to equal about 55.6 degrees. So angle C, we can find by using the 180 degrees and subtract the other two angles. So 180 minus 42 minus the 55.6. And that's going to give me then 82.4 degrees. So C was the biggest side, so it should be the biggest angle. So that looks pretty good. Okay. Let's look at this last example here and see what we can come up with. So a vertical 45-foot pole is placed on a hill that is inclined 17 degrees to the horizontal. How long a wire is needed if the wire is placed 5 feet from the top of the pole and attached to the ground at a point 32 feet uphill from the base of the pole? So they made us a drawing. So they're given this hill. There's the 17-degree incline is here. Here's the pole they're talking about. I may want to redraw this here a little bit. So they're saying this is 17 degrees over here. And then they're drawing this pole here. This pole is 45 feet. But notice how we're attaching the sky wire 5 feet below that. So the distance we need over here is actually going to just be 40 feet. So what they're looking for is the distance from where the wire is attached to the pole to the hill where it's been staked down. We want to know this distance here. So they also give us this 32. So right now, all I see is you can bring this pole on down. And this is going to actually create a right angle down here. So I can't draw very well with this pen. So let me try to draw that a little bit bigger. That's just too small for me. So we got this hill going up through here. Got this pole. And you got this wire going across here and got this pole up a little high. But notice in our triangle, though, instead of 45, we actually use a 40 since it's 5 feet short from there. We don't know the wire, but we do know this distance here is 32. So if we could figure out what this angle is right here, we're kind of home free. We could use the law of cosines to find this opposite side over here. So what we can pick up on is the only angle they gave us is 17. But they also have this pole is going to be perpendicular to the ground zero. So remember, in a triangle, 3 angles of a triangle have to add up to 180 degrees. So if I have, or actually, yeah, let's do it that way. So I have 180. If I subtract the 90 and subtract the 17, 180 take away 90 is going to be 90. 90 take away 17, well, 90 take away 10 would be 80. 80 take away 7 would be 73 degrees. So what they're saying is this angle over here is 73 degrees, but notice that vertical angles are the same measure. So this angle here is actually going to be 73 degrees. So by doing a little bit of manipulation, we can kind of see this interior angle is going to be 73 degrees. So using inverse cosine, I believe, because we do know the opposite angle, opposite side, and the adjacent sides. So this is going to be the opposite. The 32 is going to be the adjacent. and this is going to be the adjacent. And since we're looking for the side, we want to go like the opposite square, but I'm going to go ahead and just take the square root of both sides. So we have the opposite is going to actually equal the adjacent squared, which is 40 squared, plus the adjacent squared, which is 32 squared, minus, I don't know why I put it. It looks like a 0 there, not a power of 2. So 32 squared minus 2 times the adjacent, which is 40, times the adjacent, which is 32, times the cosine of that included angle, which was 73. So if I do that math, that'll give us our solution. And remember, our mode is still in degrees, so we're okay there. So the second square root, and if we put that math in there, so 40 squared plus 32 squared minus 2 times 40 times 32 times the cosine of 73. And we're good, hit enter. That'll give us our opposite side length. If we round that to the nearest tenth, that'd be 43. Well, since the other numbers are rounded to the nearest whole number, we would just round that to the nearest whole number. So 43 feet would be our length of our wire. Okay. Does that make sense? And we didn't find the other angles, but we'd have to figure out those other angles to figure that out. But yeah, it looks like this and this are very close in length. So I'm kind of buying into that distance. So our wire is going to be 43 feet long. All righty. That concludes the lesson on the law of cosines.